Okay, so let's proceed ahead. Last time in this particular section, we have been discussing combinational and digital circuits in particular. So just to quickly recap, two important digital circuits that we discussed and that we will be using now onwards is the decoder circuit. So how does decoder circuit work? It's a circuit which allows us to select one or activate one of the many outputs. Okay, so it helps us select or activate any of these output. So the truth table looks like this. So you have three input lines for this particular one. If you have three inputs, you will have 2 to the power 3 output lines. That's why it is called 3 to 8 decoder. If we have 5 inputs, then we will have 2 to the power 5 output lines. Okay, and only one of them can be active at a given instant of time. So when the 3 input line has all 3 zeros, then only output 0 will have value 1, which means that only output 0 will be active. Okay, similarly, whatever value you specify, let's say when the input, all 3 input has 1 1 1, output number 7 will have the value 1. All of them will be 0. So this circuit we are going to use in our processor development. Another important circuit that we discussed was MUX. So MUX helps us connect one of the many inputs to the single output. Okay, so here is an example of 2:1 MUX. So when I say 2x1, I read it like 2:1, which means that there are 2 input lines and 1 output line. Now these input lines can be a 1-bit input, can be multiple bit inputs. Okay, so the select lines help us connect one of these 2 inputs to the output. If the select value is 0, then whatever the value at A is will be placed at the output C. If I put the select value to 1, then whatever the value of B is here, it will be placed at the output C. So it is just acting like a gate, which is passing only one of the input to the output. Okay, the real gate, not the logical gate, the real gate, which is allowing one of the inputs to pass to the output. Okay, now here in this example, you see 0 being placed here, 1 being placed here. For your exam, or in exam, do not worry about select line can go up here, can be represented up here. 0 may be placed here, 1 may be placed here. It doesn't mean, you should not be getting confused with this. So 1 means whenever the select value is 1, this input will be connected to the output. Okay, so as I said, this is 2:1 MUX. Each input is 1 bit wide. We can also have 2:1 MUX, but each input here this time is 32 bits wide. So if this is 32 bit, the output should also be 32 bit. Okay, so when the select value, for example, if it is 0 here, when the select value is 0, this 32 bit will be connected to this 32 bit output. Okay, similarly, this is 2:1 MUX, so we can also have more input lines at the in a MUX. So here 4:1 MUX, it could be X bit input, maybe 1 bit, 2 bit, 4 bit, or whatever. Okay, but the select signal will now be 2 bit wide. Okay, because we have 4 inputs, how can you select any one of the input from these 4 possible inputs? So the select value, this select line should be 2 bits wide, so that you can represent values starting from 0, 1, 2, and 3. Okay, so if this the collective value of the select signal, the 2-bit value is, let's say, 2. Okay, so it will connect whatever the data is placed at C input to the Z input output. Okay, so this is how multiplexer works. Okay, any question? We are just recapping. You will end up using multiplexer a lot. If you have any confusion or questions, you can ask me now.